In this first video, we're going to review the process of finding confidence intervals for proportions that we did back before spring break. And I included some text on here for your reference. So if you want to save this PDF file somewhere to refer to, that's a worthwhile thing to have. There's a lot of text here, but it's just explaining everything I said in words. The main thing is that in this picture that I've drawn up here, this is to remind you what we mean when we say that we're trying to capture the middle 95% of our sampling distribution. Can't really quite see it on here. Let me draw the bigger, but remember when we draw one of these curves, we're drawing the tick marks in the center. The size of the tick mark is what I'm calling sigma in the picture, and I'm only using that letter just because it's such a small space to write things. I didn't want to write the words out. But that's the standard deviation that we find. And remember, when we're using a sampling distribution, we refer to standard deviation as standard error. So in problems, you'll be asked to find the standard error. That's using this formula. And it means the size of the tick marks in our normal distribution. So that's really the main thing. In the problems that you'll see in MyLabs Plus, there's a variety of confidence intervals, but I haven't seen any other than these, depending on the random numbers that you come up with in the when you do the MyLabs Plus. You may not see all of these, but I haven't seen any that weren't these. So if you see something besides these, let me know, and I'll tell you how to deal with it. Finally, there are lots of video explanations of why this thing is true, and I did not make one just because there were lots of them out there. So there's a link here for a particular one that explains where those z values come from. They just come from the table that we use. It's not a hard thing to do, but if we only ever look at particular confidence levels, then it doesn't really matter. We don't have to look up new ones. All right, so let's work through an example, and then I'll ask you to work through an example on your own. There'll be a follow-up video showing you what you should have gotten when you answered those questions, and then there'll be one more problem for you to take a picture of your paper and upload it for me. Okay, so here's the process. When we're trying to find a confidence interval, we have some data that we've collected. In this case, the P, and I should say this here, the P that we're estimating in this case is the proportion of all college students. So this is a population proportion. So this is the proportion of all college students who would have answered yes, if we could ask all of them. So that's the P, and we're trying to get an idea of how big that P is. And so to do that, we're collecting a random sample of 1,200 people. We're figuring out the proportion just for that sample. That's our P hat. So that'll be our sample proportion. 405 out of the 1,200 people we asked actually said yes. And to 2 decimal places, this is 0.34. Make sure that calculation works out for you. Sometimes they'll refer to this as the point estimate. In other words, if you had to give a guess, a single number guess for the value of P, this would be your best single point guess, single number guess. So they'll call that a point estimate sometimes. The standard error formula, because we don't know what P is, we can't use P in the standard error formula. So we say, well, it'll be approximately the same thing that if I had used P hat. So my standard error is going to be 0.34 times 1 minus 0.34 divided by 1,200, and that's all under the square root sign. So some of you are doing that in class. If you're having trouble with that, just reach out and I can help you out with your calculator. But we should get 0.0137. That's what I got. The most common error there is not having that division by 1,200 before you take the square root. So you want to do all that stuff under the square root sign and then just take the square root of that answer. So remember, that's the size of the tick marks. So in our original picture up here, that number, that standard error number, is how far apart these tick marks are. That's not the same as how far out we need to go to capture 95%, right? That's just how big a tick mark is. to know how far out we have to go to capture 95%, we need to take the size of our tick mark and then multiply it by these magic z-scores that we found. So in this case, since I'm on a 95% confidence interval, the z-score, I'm going to use the magic z-score is 1.96. It's always going to be 1.96 for 95% confidence interval. And that's how many standard deviations I need to go. So it'll be 1.96 times my answer to step 2. And that'll be approximately 0.027. So that's my margin of error. Back in the terms of the picture, that's how far I need to go in each direction from the center. I need to go out 0.027 and go over 0.027 that way. The tick mark size is 0.01347, and the amount I need to go out is a total of 0.027. Okay, so it's two different things. Margin of error and standard error, two different things. So our confidence interval calculation then, we just do p hat minus margin of error and p hat plus margin of error. So remember, p hat was 0.34, margin of error was 0.027. So that'll be the lower number in my conclusion. So that's going to be 0.313. If I do p hat plus margin of error, I get 0.367. So those are the two limits on my confidence interval. So I'm 95% sure that the true value of p, remember p is this unknowable proportion of all college students who would answer a certain way, has to be between 0.313 and 0.367. So that is, we're saying if I turn this into a percentage, the percentage of students who would say yes to this question, we think is between 31.3% and 36.7%, just converting those proportions to percentages. And that's it. So on the D2L, there's a link to a set of problems. I'd like you to try. There's two problems there, just like this, with the 5 steps laid out. I'd like you to try the first one and then watch the video that follows to check your answer against my answer. And then the second example on that other PDF, I want you to just do that on a blank piece of paper and take a photo of it and upload it to D2L at the link that's given.